Welcome to Conditional Probability. This allows us to use changing information to calculate probabilities. We'll still be using the probability formula, but it involves a reduced sample space and a reduced event space. So here's an example that would be just a normal probability question. If you have 50 people at a party, 28 have blue eyes, 20 have red hair, and 8 have blue eyes and red hair. So if we look at this as a Venn diagram, the intersection, the middle part is 8. That leaves us 20 in the blue eyes and 12 in the red hair, with 10 having neither blue eyes or red hair. So let's continue our question. Someone at the party took the last cupcake. What's a probability it was someone with blue eyes? So the probability of blue eyes is 28 had blue eyes out of the 50 that were at the party, giving us 14 out of 25. Now let's introduce a condition. So Sally was at the party and said she saw the person from behind and they had red hair. What's the probability the person has red hair and blue eyes given they have red hair? So this is a reduced sample space. So the number of people with red hair is 20, and it's also a reduced event space because the people with red hair and blue eyes is 8. So this gives us the probability of the red hair and blue eyes, given the red hair, as 8 out of 20. So 2 out of 5. So the probability of A/B, pronounced probability of A, given that B has occurred, is A intersection B over B. Or as a probability, or using the probability notation, it's a probability of A intersection B over the probability of B. So let's use these formulas. So in Year 11, 30% of the students study English Advanced, 40% study Studies Religion 2, and 10% study both. So the first one we'll look at is the probability that a student studies English Advanced given they study Studies Religion 2. So our formula, probability of English given SOR2, is the probability of the intersection of English and SOR2 over the probability of SOR2. So that's 0.1 over 0.4. For the second example, the probability that a student studies SOR2 given they study English Advanced, well, that's the probability of English intersecting with SOR2 over the probability of English. So that's 0.1 over 0.3, which is a third. So note with independent events, if the probability of A is not affected by whether or not B has occurred, then the probability of A given B is just equal to the probability of A. So let's look at some example where events may be independent. So note these down. In an event, the probability of A is 0.5, of B is 0.4, of C is 0.25, A intersection B is 0.2, A intersection C is 0.1, and B intersection C is 0.1. We're going to determine which of these events are independent of the others. So we're going to use our formulas. So probability of A given B, so the probability of A intersection B over the probability of B is 0.2 over 0.4, which is 0.5, and that equals to P of A. So using our rule, it says, therefore, A and B are independent. The probability of B given C. Probability of B intersection C over the probability of C is 0.1 over 0.25, which is 0.4, which equals the probability of B. So B and C are also independent. The final one, probability of C given A, probability of C intersection A over the probability of A, is 0.1 over 0.5, which is equal to 0.2. But C was equal to 0.25, so it doesn't equal to the probability of C. So A and C are not independent. Thank you.